Okay, so we just looked at a linear trend, and a linear trend is when our data seems to follow um, a linear pattern. So the data with the goose, it wasn't a perfect straight line, but it had that straight line quality, and we were able to put a line of best fit in there and make some assumptions. Now we're going to look at what's called linear relationships, um, and the reverse to that would be non-linear relationships. So let's look at when Rye was 13 years old, his parents invested $10,000 for 5 years to help pay for his post-secondary education. They had the choice of a simple interest account that pays 3% annually, um, or a compound interest account that pays 3% annually. Okay, so the difference between that is with a simple interest account, you are only earning interest on the original amount invested. So every year, you would earn 3% of the $10,000 extra. You're going to earn the same amount every year. With a compound interest investment, not only do you earn interest on the original amount invested, but every year you add a little bit of interest to that investment. And you're going to earn interest on that as well. So you earn a little bit more interest every year. So the first thing we're going to do is create a table of values for both investments. So I have those done here. So, some stuff stuck together here. All right. So the simple interest graph you can see here. So we start at 0 years, which is just the beginning of the investment. No time has passed. And you can see they invested $10,000. So every year after that, until the end at 5 years, we earn 3% interest. So 3% of $10,000 is $300. So you can see every year we add $300 to the original investment until at the end of 5 years we have $11,500. Compound interest is a little bit different. So at the beginning we still have $10,000 invested, and in the first year we earn 3% of that interest. So my first year for both investments looks exactly the same. We earn that $300 interest at 3% of the $10,000. But the second year for the compound interest, we earn 3% not of the original $10,000, but of this $10,300. So in the second year, we actually earn $309 interest. And in the third year, instead of earning interest on the original $10,000, we earn it on the $10,609 from the year before. So we're earning $318 interest. And so on and so forth until at the end of 5 years, we have $11,593 in interest. Okay. So the question says, what do you notice about the patterns in each column for both investments? So let's look at the years. So what's happening to the years in each table? So for each table, the number of years increase by 1. So they both go up by 1. Both increase by 1. But when we talk about the value of the investment, it is different for each table. So the simple interest, I'll call it SI, increases by 300 each time, while the compound interest, I'll call it CI for compound interest, increases by more every year. So in the first year it increased by 300, and in the second year it increased by 309, and then 318, 328, and then 338. Okay. So then it asks us to graph each set of data. So we would do a scatter plot, and this is what they would look like. And there is a line of best fit a little bit in there. So in the first one, we see the years are our independent variable for both of them. And then the dependent variable is the value of the investment, because the value depends on the number of years that have passed, right? So you can see each point for the 5 years graphed on each graph. So what do we notice about the pattern in the points of each investment? So is there a linear relationship? So before I can answer that, I need to know what is a linear relationship. So a linear relationship is a direct relationship between the x and y coordinate. All the points on the graph of a linear relationship lie along a straight line. So a linear trend was when the graph kind of went in the pattern of a straight line, and I could draw a line of best fit, and we could make some assumptions that way. A linear relationship is when the points, if I connect the dots, it follows a perfectly straight line. So if we look at the first graph, we can see that where the dots are connected, it formed a straight line. So this is a linear, actually I'm going to put that somewhere else, just for later. So this one is a linear relationship because the points connected form a perfectly straight line. If you look at the compound interest graph, the line that's drawn there connects the first 2 points, and it doesn't hit any of the other ones, any of the other 4. If I were to actually connect these points, the line wouldn't be straight. It would kind of curve up a little bit, because as you see, each time I'm getting a little bit further away from that line. So it would actually kind of curve up a bit. So this is what we call a nonlinear trend. So basically it's linear or it's not. It forms a straight line or it doesn't. One or the other. Okay. So how does the graph relate to the table of values? So what I notice here is that for each point in both graphs, the year increases by 1 each time. And if you look, so this is by 1 year each time we increase, which makes sense because if you look in the table of values, our year increases by 1 each time. If you go back to the graph and look at our dependent variable, in the first graph, the point increases or goes up by 300 every time. And that's what my value or my independent column increased by. In the second graph, it follows the same idea, but how much the points increase by change just like they do in the table. So it goes up by 300, and then 309, and then 318, and then 328, and then 338, just like these values do here. Okay. So the last question, did Rise parents chose the compound interest account? Did they choose the right investment? Well, if you look at how much was in the account at the end for both investments, it's on a highlighter. If the simple interest had 11,500, the compound interest had 11,593. They definitely made the right choice. It's not a big difference. It's only about $93. But in general, with investments, compound interest tends to build interest more quickly, and so it's usually the better choice. Before we finish, I want you to note something, which didn't really ask about, but we can talk about. I want to look only at the linear interest investment. If you remember back to grade 11, we learned about slope, and slope is rise over run. And if I look at the slope of this line, Well, let's draw back in what I had. Every time, between every 2 points, I go over 1 and up 300. So if I want to find the slope of this line, I would do the rise, which is 300, over the run, which is 1, which means my slope would be 300. Now that we've seen the connection between the table of values and the graph, I can do the same thing with my table of values. So this is my rise, because we said that tells us what my graph is going up by each time. And this is my run. So if I want to find my slope, I can do 300 over 1, which is 300. Okay, so you can easily find your slope from your table of values, just like you can your linear relationship graphs. And I just wanted to point that out. The other thing I wanted to point out is this value right here. This is what we call our y-intercept on a graph, and it is where the graph crosses that y-axis, and it crosses it at 10,000 in both places. So our, what we call our y-intercept, I just put y-int for both graphs, is 10,000. On the table, we can see that right here. Oh, again, that is not a highlighter. Right here. And it's when my independent variable, my x value, is 0. So whenever that x value is 0, that tells me what my y-intercept will be, where it will cross on that axis. Those are things we're going to talk about in the next few sections. I just wanted to point them out now so that we see them and they're not new when we run into them.